Hello everyone, welcome to my class. Today we will talk about dual nature of matter or dual behavior of matter. So far we have learned that electromagnetic radiations have a dual nature, that is wave and particle like character. But in 1924, Louis de Broglie, he observed and stated that all moving material particles have dual nature, that is, they possess wave as well as particle like character, and the waves which are associated with matter are called matter waves. These matter waves are quite different from electromagnetic radiations or electromagnetic waves. And he tried to correlate the wave as well as particle-like character in an equation, and that equation is called de Broglie equation. That is, lambda is equal to h upon mv, where lambda is the wavelength, h is Planck's constant, m is the mass, and v is the velocity. We can derive de Broglie equation simply by using two equations, that is Planck's equation as well as Einstein equation. So let us talk about the first equation, that is Planck's equation. According to Planck's equation, E is equal to h nu, and we know that nu is equal to c upon lambda. So E becomes equal to hc upon lambda. But according to Einstein equation, E is equal to mc square. So from first and second equation, we can conclude that hc upon lambda is equal to mc square. C gets cancelled out, so it becomes h upon lambda is equal to mc, where c is the velocity of light or of electromagnetic radiation. If we replace c by v, that is the velocity of a material particle or a moving material particle, then the relation becomes h upon lambda is equal to mv, or lambda becomes equal to h upon mv. This is called de Broglie equation. We know that mass into velocity is called momentum. So lambda is inversely proportional to momentum. So momentum mv, that is inversely proportional to wavelength lambda. Next is relation between kinetic energy and lambda. Now this relation can be calculated or derived simply by using de Broglie equation and kinetic energy equation. We know that kinetic energy is equal to half mv square. Half mv square. So what we are going to do, we will multiply both sides of this equation by 2m. So the equation becomes 2me is equal to half mv square multiplied by 2m. Or we can say 2me is equal to m square v square, or mv will become equal to root of 2me. If we substitute the value of mv in de Broglie equation, that is lambda is equal to h upon mv, we get lambda is equal to h upon root 2me. So this is relation between kinetic energy and wavelength. Next is limitations. Limitations of de Broglie concept. The question arises, does de Broglie hypothesis has any relevance to macroscopic matter? Now for that, consider a car having mass 100 kg moving at a speed of 100 meters per second. Let us calculate lambda for it using de Broglie equation. Lambda is equal to h upon mv. Substitute h, which is Planck's constant, 6.626 into 10 to the power minus 34 kilogram meter square per second. Substitute m here. M here is 100 kilograms. V here, V here is 100 meters per second, we will be able to calculate lambda, which comes out to be 6.63 into 10 to the power minus 38 meters. Now see, this wavelength is very small. So practically we are not in a position to see the wave having such a small wavelength. So that's why we don't feel the wavy nature of the car when it moves, because the wavelength of the radiation emitted is very less. Wavelength of the wave is very less. So that's why wave nature or de Broglie wavelength is not observable in the macroscopic matter. Next is evidence to support wave and particle nature of electron. First of all, evidence in favor of particle nature. We all know that an electron has a particle-like character. Particle means it has mass, it possesses charge, it has energy, so it has got momentum, mass into velocity. So that means it has got particle-like character. Now it can be further supported by scintillations, means when electron is allowed to strike zinc sulfide screen, scintillations are produced. So scintillations just point out the particle nature of electron. Number 2, black body radiations. They also show that electron possess what type of character? That is the particle-like character. Similarly, photoelectric effect also support the particle nature of electrons. Now let us talk about the evidences in favor of wave nature. So in favor of wave nature, we can discuss Davison and Germer experiment. Now in 1927, C.P. Davison and Germer performed a diffraction experiment on the electron. A beam of electrons emitted from a red hot tungsten filament was just subjected to an electric field. Why the beam of electron was subjected to electric field? So that the electrons can be accelerated, their speed can be accelerated. So then these highly accelerated electrons were allowed to strike against a sample of nickel. So when they strike nickel crystal and the pattern was observed on the photographic film, we got concentric circle. Concentric circles means dark and bright rings called diffraction rings were observed on the photographic plate. Now diffraction was already observed in X-rays, and X-rays was revealed that X-rays possess wave-like character. So when the similar experiment was observed on X-rays and the diffraction pattern of X-rays was studied, then the diffraction pattern of X-rays and the diffraction pattern of the electrons so generated, it was almost same. So from there it was concluded that electrons, means the waves associated with electrons, also possess the wave-like character or the wave nature. Similarly, Thomson, he also repeated the similar type of experiment. G.P. Thomson in 1928, he used a thin foil of gold instead of nickel crystal, and he also observed the similar kind of the diffraction patterns for the electron beam. That also suggested the wave character of electrons. Next is, what is the difference between particle and wave? Number 1 is, a particle occupies a well-defined position in space, means highly localized position. But a wave is delocalized, or it is just spread out in space. Number 2, when a particular space is occupied by one particle, the same space cannot be occupied simultaneously by any other particle. So we can say particles do not interfere, whereas waves can interfere. Number 3. When a number of particles are present in a given region of space, their total value is equal to their sum. That is, it is neither less nor more. But when a number of waves are present in a given region of space, due to interference, the resultant wave can be larger or smaller than the individual waves. That is, interference may be constructive or it may be destructive. Particles can be counted, but waves cannot be counted. So next is difference between electromagnetic waves and matter waves. So number 1, electromagnetic waves are the waves which are associated with electric and magnetic field. However, matter waves are not associated with electric and magnetic field. EM waves, they do not need any medium for propagation. Light doesn't need any medium for propagation. But matter waves, for example sound waves, they require medium for propagation. Electromagnetic waves travel with the speed of light, but matter waves, they travel with lower speeds, not even constants, and it is different for different matter waves. Electromagnetic waves, they obey the equation lambda is equal to C upon nu, whereas matter waves, they obey lambda is equal to H upon mv. EM waves are highly quantized, means their energies are quantized, but matter waves, their energies are not quantized. EM waves, they cover a full range of spectrum, but matter waves have very short wavelength. Coming to the last, that is derivation of Bohr postulate of quantization of angular momentum. When we talked about Bohr's model, we said MVR, that is angular momentum, is always whole number multiple of h upon 2 pi. That is MVR is always equal to NH upon 2 pi. Now it can be derived. And for the derivation, just consider an electron to be moving in a circular orbit of radius r around the nucleus. And if two ends of the wave meet to give a regular series of crust and trough, it is in phase. And in case they don't, then the electron wave is said to be out of waves. Now, starting from the idea that circumference of the circular orbit must be an integral number of wavelengths, means 2 pi r should be equal to n lambda. Circumference of the circular orbit will have n number of waves in it. So 2 pi r is equal to n lambda. Substituting lambda, lambda is equal to h upon p. So it becomes 2 pi r is equal to nh upon p. We know that P is equal to mv. So it becomes 2 pi r is equal to nh upon mv. If we rearrange, we will get mvr is equal to nh upon 2 pi. That's all about derivation of Bohr's postulate of quantization of angular momentum.